look at our next section in chapter 9. Okay, so moving on to translations today. Friday we went over reflections. Okay, so today we're going to go over translations. So translation is also considered a slide. Okay, so we're sliding our figure to a new point. Okay, so sliding that figure, all of its points to a new one. Okay, this is a transformation. Quiet now, please. This is a transformation that moves all points of a figure the same distance and in the same direction. Okay, so we're taking all of these points, we're going to move them the same length or distance, okay, and in the same direction. So a translation is a function that maps each point to its image along a vector called the translation vector. Okay, so a translation vector has each segment joining a point in its image, and it has the same length. Okay, so if I go from point A, okay, that's our pre-image, to A prime, that is our image. That distance or length has to be congruent or equal to the length of your vector. Okay, so each of these segments here would be congruent. Okay, this segment is also parallel to the vector. Okay, so it's also parallel, meaning they're never going to intersect. So again, that segment from A to A prime and your vector have to be parallel. If they weren't, that means your vector would be going in the opposite direction as your segment. Okay, so your segment has to go in the same direction. That's why they are parallel to each other. Okay? So a translation vector shows length and direction and is named with a symbol in lowercase letters. So the one that they have an example of here is vector V. Okay, so if I have my lowercase letter V, that symbol we use to label a vector is a segment with like a half an arrow drawn in. Okay, so that would symbolize a vector. All right, so first example here, use the figure and the given translation vector, then draw the translation of the figure along that translation vector. So our translation vector for this one is vector P. It's this one right here. So I need to take each of my pre-image points and move them that same distance as vector P. Now, I do have these dashed lines drawn in for you. If I didn't, you would take a ruler and measure out how long your vector is, and you'd have to do that same distance in the same direction for all of those points. However, I do have each of those dashed lines drawn in. So from M to M prime along that vector is here. L to L prime is here. O to O prime, and N to N prime. Okay, and then I could connect each of those points to create my image. Okay, and again, they were already drawn in for you. If they weren't, you'd have to measure out that vector, see how long it is, and then mimic that for each and every point. All right, questions so far before I continue? So with our vectors, we have a component form. Okay, so a vector in the coordinate plane can be written as a B. Now notice your brackets here are kind of arrowed. They're not rounded like a coordinate point. So when we write out a vector in component form, we use these arrowed brackets to do so. Okay, so that's how we would write out a vector. That's how it's going to be labeled on examples that we do. Okay, this A value in this form, okay, so that's your first value right here. That represents the horizontal change. Okay, so that's your left and right, how it will change left and right in the coordinate plane. And B, that value there, okay, that is the vertical change. Okay, so that'll change how it's moving up and down. So at the right, I have kind of an example of this. So we have this segment from C to D. Okay, so we want to use this vector right here, 2, 4. So that's how they're moving point C to point D. So this 2 means you're going to go right 2 units from your point. So first I would go right 2 units. This -4 here, since that's our vertical change and it's negative, I'm going to go down 4 units. So to get from C, we went right 2 units this way. Okay, and then from that point, we would go down 4 units. Okay, and that would get us to point D right there. Okay, so that's how our vector is used. So again, this B value is going to move your figure up or down. Okay, and if you have a value for A, that's going to move your figure left and right. All right, then looking more at a translation in a coordinate plane using your vector. So again, we have our standard form for a vector here, AB. This point right here is your pre-image coordinate. Okay, so the coordinate you're starting with. Now to get to your image coordinate using your vector, your A value from your vector goes with your X value in your coordinate. Okay, because both of those move things left and right. And your B value goes with your Y in your coordinate. Okay, because those two move a figure up and down. Okay, so to change from your pre-image to your image, all we have to do is add our original X value to our A value in our vector to get our new X value here. And for our new Y value, we just have to take our original Y value, add in our B value from our vector. Okay, and that will give us that Y value in our new image. So an example on the coordinate plane like that below, from P to P prime. My original XY coordinate here is -2, 3. Okay, so that's your original. Now up here, P prime, I'm taking -2, which was our original value, right? And I'm adding 7. Okay, that means 7 is part of your vector. Okay, and then our Y value is 3. Okay, so I have 3, and I'm adding on a 4. Okay, so 4 must also be part of our vector. It's your vector. Okay, so they're using this vector of 7, 4. Okay, so to get from point P to P prime, they're taking -2 plus 7, which is 5, and 3 plus 4, which is 7, to get that new coordinate of P prime. Okay, so you're just adding your X value to your A value and your Y value to your B value. You might have to find your vector sometimes. I'll get there. I'll show you how to do that too. Okay, questions on that before we do some actual examples on a graph? It'll be a little bit easier once we actually start doing the example. All right, so for these examples, we want to graph each figure and its image along the given vector. So in letter A, we have triangle EFG with the given vertices. Okay, and we want to translate it along this vector 2, 5. So I want you guys to graph these 3 points. So point E is at -7, -1. Okay, so that's point E. Point F is at -4, -4. And point G is at -3, -1. And if you would like a ruler to make everything straighter, I can get you a ruler as well. So I have each of my coordinates. Now what I want to do is use my vector that I was given. Okay, that's right here. Okay, that 2, 5 is your vector. It's not a coordinate point. So this 2 is your A value. That's moving it left or right. Okay, since it's positive, it's going to move right. So using my vector, I'm going to go right 2. My B value is 5. That's my up or down motion. Since it's positive, I'm going to go up 5. Now I'm going to show you 2 ways to do this. Okay, 2 ways. First way, my original point E is at -7, -1. And I want to move it along this vector of 2, 5 to get E prime. So to find E prime, I'm going to take -7, my original X value, and add on my A value from my vector, which is 2. Okay? Then I also need my new Y value, so I need to take my old Y value, which is -1, and add on my B value from my vector, which is 5. Okay, so E prime will be at -5, +4. And then I can just plot that point. Okay, so E prime is now at -5, +4. So that's one way we can do this. Another way, finding F prime, we can just use our graph. So from point F, I know I have to go right 2 and up 5. So I'm going to count right 2 units. Okay, then from that point, I want to go up 5 units. So 1, 2, 3, 4, 5, and then I can plot my new F prime point. Okay, I'm going to do the same thing with point G. Okay, so I need to go right 2 units from point G. So 1, 2, and then go up 5 from that point. 1, 2, 3, 4, 5 to get G prime. And then I can connect all 3 of my points to make my image. Okay, now just like on Friday, however, I do want you to write out each of your prime coordinates. So right now I have E prime already. I need to write out what F prime and G prime are. Okay, so F prime from your origin is at -2, +1. And G prime is at -1, +4. Okay, so again, just rewriting each of those prime coordinates down. Questions? All right, try letter B. plot each of those points to create that square and then move it along that given translation vector. All right, so here is my pre-image, so my original, right? I plotted all 4 of those points, created that square. Now I want to use this translation vector here of -3, -4. So that means I need to go left 3. So left 3, that's what that negative means. And then down 4. Okay, so from each point, I'm going to go left 3 and then down 4. So for J, left 3, down 4. Plot my point. That's J prime. Okay, left 3, down 4. Plot my point. Left 3, down 4. That is L prime, and then M. Here. Okay, so there's my image. Okay, after I move it, then each of my coordinates, I would have J prime is at 0, 0. K prime is at 2, -2. L prime is at 4, 0. And M prime is at 2, 2. Okay, so again, make sure you are writing out those prime coordinates. Any questions on letter B? Good job. All right, then last one here. In one part of a marching band's performance, a line of trumpet players starts at position 1, marches to position 2, and then to position 3. Each unit on the graph represents one step. Describe the translation from position 1 to position 2 in function notation. So this is where we're actually going to write out a vector of what's happening. So from position 1, which is right here, to position 2. What I do when I have to write out a vector is I pick a point from my pre-image. So I'm just going to pick this top one here. I need to pick the same point in my image, so the one that I'm moving to. Okay, so in position 2, that would be this point right here. Now I need to see how it's moving. Well, I know we're moving to the left this way, right? Okay, now if I count each of those, that's 6. However, if I look down at my scale here, each of those go up by 2. Okay, so this will be going left 12. So is it positive or negative? It is negative 12. Okay, because I'm going left those 12 steps, right? So now what I want to do is write a vector of what's going on from position 1 to position 2. Okay, so again, for a vector, you need to write those arrowed brackets. Now, since I'm moving left, does that coordinate with my A value or my B value in my vector? A. Okay, so that means it comes first. So at first I'm moving left 12 units. Now I'm not moving up or down, am I? No. So since I'm not moving up or down, my B value would be 0. And then I could end my vector with that arrowed bracket. Now, make sure when you are writing your vector, you're writing it with these brackets. If you write it with parentheses like a coordinate point, you will get it marked wrong. Okay, a vector is not a coordinate point. So you should not be using that type of parenthesis. Okay, so we're not using parentheses. You have to use the arrowed brackets. Does that make sense? Awesome. Any questions?